So, my dear students,
Okay, sir.
in the last period, we have studied about the various types of the unit cells. We have seen the first one, which is known as the cubic or primitive kind of unit cell. In this cubic or primitive kind of unit cell, we actually study the cell which has 8 particles present on its 8 corners. You can see that each particle present at its corner, and this is what we can, this is where we have shown the particles in the form of just the points. But here you can see the particle in the form of sphere. You can see that these are the 8 particles present at the 8 corners. I hope you can see them now. I'll just show you. Yes, now you can see it here. If you look into this, you can see that each particle is present on 8 corner. You can see here, this is the another particle on the second corner. Then this is the third particle on the third corner. This one is the fourth one. This is the fifth one. See, in the previous figure we have shown them in the form of the, then this is the sixth one that we have. Then this is the seventh one, and the eighth one would be here. This is the eighth one that we have. So at the 8 different corners, we have 8 particles, and you can easily understand now that this is the 1/8 of the part of the particle that is present into the unit cell. If you do not understand it, I will explain it some other way. But this is how we understand the primitive unit cell, my dear students. Now let us understand one more unit cell, which is known as the body-centered unit cell. So let us first look into here itself. Let us study about the body-centered unit cell here itself. You can see that here this is the body-centered unit cell, my dear student. So this is the unit cell which is known as the body-centered unit cell. In this you can see that there is one atom present exactly at the center of the body of the unit cell. So this is the atom that is present at the center of the body of the unit cell, and as it is present at the center of the body of the unit cell, we consider it as a body-centered unit cell. Apart from that, we definitely have 8 particles at 8 corners. So we can represent it in some other manner. Let us study, or let us have a look to that even. Let me show it to you, my dear students. Yes, here you can see that this is the red one which is at the center, and then we have the 8 particles at the 8 corners. You can easily understand 1, 2, 3, 4, 5, 6. Then the 7 and 8 are just at the back of this particle. So this is how, my dear students, we understand about the body-centered unit cell. Now we want to study about the face-centered unit cell. So in face-centered unit cell, apart from the 8 corner, my dear students, you can see that we have various faces. So you can see these are the various faces. We have 6 faces. This is 1, 2, 3, 4, 5, and this is sixth one, which is exactly at the back. So if you are standing over here, my dear student, if you are standing here, then up, like in front of you, you have second number face, and at the back of you, you have 6 number face. On the left hand side, first number, and right hand side, third number. Above your head, you have fifth number, and under your leg, you have fourth number unit cell. And this is how these unit cells are present into the face-centered unit cells. And then apart from this, they definitely have these particles at the various corners. And when it comes to the end centered, you please need to remember that we have three pairs of opposite faces, three pairs of opposite faces. So one pair is, this 1 and 2. This is like left and right. The another pair is front and back. And the third pair is above and under. So out of these three pairs, if apart from the 8 particle, apart from the 8 corners, if the particle is present at any one pair of opposite faces, we call it end-centered unit cell. So let us take a look towards the end-centered unit cell, my dear students. Let's move and understand the end-centered unit cell. Please remember that the particles are actually these spheres, and they are bigger than what you can see here. Here we have just represented the particles in the form of points, and that is why we study them in this manner. Here you can see on your screen the kind of unit cell. This kind of unit cell is known as the end-centered unit cell. In the end-centered unit cell, apart from the 8 corner, 1, 2, 3, 4, 5, 6, 7, and 8. Apart from the 8 corner, there are 2 particles present at the opposite faces. So they may be here, or they may be even located at here, or you can even, so they can be even here, here and here. So here we have shown them in the opposite faces of the pair, which is above and under. This may be the left and right, or this may be the front or back. And this is how, my dear student, we understand about the uh, unit cell, which is known as the end-centered unit cell. So we actually study the various types of unit cell. In these various types of unit cell, my dear students, we study about the various unit cell. Do you know what are these various unit cell? Can you repeat? Can you tell me what are the various types of unit cell that we have seen?
Primitive.
So first we have
ABC,
seen,
alpha, beta, gamma.
first not alpha, beta, gamma, beta. First unit cell that we have studied was the primitive unit cell, where you have the particles at 8 corners. Then, my dear students, we have the second type of unit cell, which is known as the body centered. In this body centered unit cell, please remember that apart from the 8 corners, we have one particle at the center of the unit cell. Then the third one you have is known as the face centered unit cell. My dear students, in the face centered unit cell, if we really study about, apart from 8 corners, we have particles on 6 faces. And then, my dear students, we have the last one. The last one we call it as an and-centered unit cell. And let us study about the last one, which is known as the and-centered unit cell. And dear student, in the and-centered unit cell, apart from the 8 corners, we have the particles present at the uh, one pair of opposite faces. One pair of opposite faces. So this is how, my dear students, we truly understand about the four types of or four various types of unit cell. Now if you have any doubt, please ask me. बच्चों अगर आपको अभी भी कोई डाउट है प्लीज पूछ लीजिए. Now these are the various 14 types of brevis lattice that we can see. So first we will study about the cubic system or cubic unit cell, where we have A is equal to B is equal to C and alpha is equal to beta is equal to gamma is equal to 90 degree. And in this cubic system, we may have primitive unit cell, face centered unit cell and body centered unit cell. And if we look into the primitive kind of unit cell, the examples are NaCl, ZnS and Cu. Then, my dear students, we have the next one, which is known as the trigonal. Here we have A is equal to B is equal to C, and it is a trigonal. Has also got the primitive kind of unit cell, where we have calcite and cinnabar are the examples. And then we have the rhombohedral, where you have alpha is equal to beta is equal to gamma. And then you have the next one, uh, tetragonal, where A is equal to B is equal to C and alpha is equal to beta is equal to gamma is equal to 90 degree. This type of unit cell may have the primitive kind of unit cell as well as the body centered unit cell. And we have the various examples like T in white, uh, SnO2, TiO2 and calcium sulfate CaSO4. Then we have the hexagonal kind of unit cell, in which you have A is equal to B is equal to C and alpha is equal to beta is equal to 90 degree, but your gamma is equal to 120 degree. And you have the various examples like graphite, zinc oxide and CDS. Then you have the orthorhombic kind of unit cell, where you have, in orthorhombic, where you have A is not equal to B is not equal to C and the angles alpha is equal to beta is equal to gamma is equal to 90 degree. Here you have the four type of unit cell you can see, primitive, body centered, face centered and end centered, and the various examples are rhombic sulfur, KNO3 and BaSO4 are the examples for the orthorhombic kind of unit cell. Then we have the monoclinic, where you have A is equal to A is not equal to B is not equal to C, and here you have alpha is equal to gamma is equal to 90 degree, but beta is not equal to 90 degree. Means beta can be any other angle other than the 90 degree. Here in monoclinic type of unit cell, we have primitive kind of unit cell and end-centered kind of unit cell. And the various examples are Na2SO4 into 10H2O. We have monoclinic sulfur. This Na2SO4 into 10H2O is also known as Globus salt. And then the last type of unit cell that we have is known as the triclinic unit cell. In triclinic unit cell, we have A is not equal to B is not equal to C, and alpha is not equal to beta is not equal to gamma is not equal to 90 degree. That means none of the angle is equal to 90 degree and none of the sides are equal. So here we have only the primitive kind of unit cell, and the examples of triclinic are CuSO4 into 5H2O, K2Cr2O7 and H3BO3, that is your boric acid, BOH thrice. You can even write it as a BOH thrice, my dear students. H3BO3 or BOH thrice, which is your boric acid. So my dear students, if you really look into the various number, there are total 14 types. You can see 1, 2, 3, 4, 5, 6, 7. Then you have 8, 9, 10, 11, 12, 13 and 14 type of brevis lattice. You can see this, and this is how we classify all the lattice into the 14 various types of brevis lattice. Now my dear students, let us study about the open structure. So let us study about the open structure when instead of actual size of the particle, only a point or a center of the particle is represented in the unit cell, it is called the open structure. So these kind of structures that we have studied for the various unit cells, these all what you can see now on your screen, they are known as the open structure. So in this open structure, instead of the actual size of the particle, you just show the center of the particle or you just show a point, and that is what it is known as the open structure of the unit cell. So my dear students, and these, so you might be aware of the open structure. Open structure helps us to explain the arrangement of the particles. So in the open structure, my dear students, we can understand the arrangement of the particles. You can see that the particles, if they are arranged in an ordered manner, they are arranged in this manner. And you can put some points somewhere here and there, and you can show the open structures. But you can see that this is how, so now you can see here, I have shown you something which is there, which is the open structure. In this open structure, I have shown you one particle at the center. Now, my dear students, if you look into this particular arrangement, you can see there are 8 different unit cell you can make, and out of those 8 different unit cell, I have shaded only one with me. If you look into this, you will come to know that out of all these 8 smaller unit cell, I have shaded one unit cell with the black color. So in this black color, you have one unit cell, so you can have this one, then back of it two, then above it three, and just next to four. So see, this is one, this is two, this is three, this is fourth one, this is fifth one, this is sixth one, this is seventh one, and that is eighth one. So there are total 8 unit cells available here, and you can see that this particle which I have shown here is present in all 8 unit cells. This particle which I have shown here is present in all 8 unit cells. That means if the particle is present at the corner, you will have always 1/8 part. If the particle is present at the corner, my dear students, you will have 1/8 part of that particle shared among all the other unit cells. Now, if you look at this one, my dear students, which I am going to show you, this particle, which is present on the face. So, this particle is shared by this one number and two number. Please remember that this particle is shared by one number and two number. So, the particle which is present on the face is one half present into the particular unit cell. So this particle is present one half into the unit cell number one, and this particle is present one half into the unit cell number two. But if you look into the particle which is shown with the dark color here, this. So this particle is present at the body center, and this particle is completely present in the unit cell. This particle is not shared by any other unit cell. This complete particle or this whole particle or full one part of this particle is present into a given unit cell. So my dear students, if the particle is present at the corner, we can say it is 1/8 present. If the particle is present at the face, it is 1/2 present, and if the particle is present at the body center, a complete one particle is present into the unit cell. So that is what I really wanted you to understand so that we can discuss it better. I hope, my dear students, you understood it well. Now let's read what is written over here. 1/8. Yes. 1/8 of the constituent particle is present in the unit cell if it is placed at the corner. So if the particle is placed at the corner, we will have the 1/8 part of it present. Then 1/2 of the each constituent particle present at the face. So if the particle is present at the face, 1/2 of it is shared with the unit cell. If a constituent particle is present at the center, that is the body center, one complete constituent particle is present in the unit cell. So this is how, my dear students, we can understand what part of the particle is present into the unit cell. Now, if we look into the simple cubic kind of unit cell, in simple cubic unit cell called primitive unit cell, we have 8 atoms at 8 corner, constituting 1/8 of it. So in a primitive unit cell, each unit cell has got 8 particle at all 8 corners, my dear students. So the particle present here at all the corners will have only 1/8 of it present into the unit cell. So this has got 1/8, 1/8, and such total we have 8 corners. So we will have one particle, one complete particle present into the primitive kind of unit cell. So we can say that thus total number of particles present in a cubic unit cell is equal to 1/8 multiplied by 8, that is 1. So we can say that in a primitive cubic unit cell, we will have one particle present per unit cell. Now, my dear students, if we look into the body-centered unit cell, in body-centered unit cell, we have 8 particles at 8 corners and one particle present at the center. So it is written unit cell 8 constituent particles are at the corners and one at the center of the body, thus combining 8 particles at corners. So 8 multiplied by 1/8, that gives us 1 atom, and at the center of the body 1 atom. So total 1 plus 1 gives us the 2 atoms. So total 1 at 8 corners and 1 at the body center. Total 2 atoms are present at the inside the body centered unit cell. Then, my dear students, we want to study about the face centered unit cell. We have constituent particles, 6 particles at at 6 faces. We have half particle, because the particles which are on faces, they are half present, and we have 6 faces. So 6 multiplied by 1/2, total 3 atoms, and we have 8 particles at 8 corners, that gives us 1 atom. So total 4 atom in the unit cell, which are 1 at 8 corners plus 3 at 6 faces. So in my dear students, in face centered unit cell, total we have 4 atoms present per unit cell. So now you can see, my dear student, here that this face is 1/2 present, or 1/2 present into the given unit cell. If it is at corner, it is 1/8 part present into the unit cell. You can see here, if it is present at the body centered, one full atom is present inside the unit cell, and that is how, my dear students, you can see even here that this is the body centered unit cell, which is completely present into the center of the body, and apart from that, each 1/8 particle or 1/8 share of this particle is present. You can even see into this, and this is how you can easily understand that 1/8 particle of each which is present on the corner. If the particle is present at the center of the body, it is completely present, and if the particle is present on the faces, then it is half shared. So the half of the particle is present in the given unit cell, and half of the particle is present in the another unit cell. So this is how, my dear students, we understand the various types of unit cell, that and what is the total number of particles present into them. Now, my dear students, we want to study about the close packed structures. So let us study about the close packing or close packed structures. In a solid, constituent particles are closely packed, leaving the minimum vacant space. So, my dear students, in a solid, the particle tries to arrange themselves as near as possible, and they want to keep the minimum space. coordination number. Now we want to study one definition which is known as the coordination number. I am going to read it for you. The number of nearest neighbor of a particle is called its coordination number. Once again, I am going to read it for you, my dear student. The number of nearest neighbor of particle is called its coordination number. So, number of nearest neighboring particle represents the coordination number. Now let us study and first the close packing in one dimension. So we are going to study the close packing in one dimension. There is only one way of arranging the spheres or particles in one dimension close packed structure. That is to arrange them in a row and touching each other. So you have been watching this where we have arranged the particles in one direction or in one you can say in one dimension, and you can see that this particle has got two nearest neighbors. Now someone says, sir, I don't want to arrange them this way. So you can arrange them. This is what it is in the x-axis. You can arrange them on the y-axis. There also you will have the nearest neighbor 2. If you arrange them on some other way, like in other manner, suppose you want to arrange them this way on z-axis. So you can even arrange them on the z-axis, but still the nearest neighbor would be 1 and 2 in any cases. So my dear students, if we arrange the solid particles or constituent particles in one dimension, then in one dimension they can have coordination number is equal to 2. So in one dimension, if we arrange the particles, we can have maximum coordination number 2. That is what we understand. So there is only one way of arranging the spheres in the one dimension close packing structure, that is to arrange them in a row or in a column touching each other. In this arrangement, each sphere is in contact with two of its neighbors. The number of nearest neighbor of particle is called the coordination number. Thus, in one-dimensional close pack arrangement, the coordination number is 2, my dear students. Please remember that in one-dimensional arrangement, the coordination number is 2. Now, let's move forward and understand something else. Let us study about the close packing in two dimensions, my dear students. Let us study the close packing in two dimensions. So when we arrange the particles into the two different dimensions, what do we see? Let us look at. If we arrange the constituent particles in two dimensions, the arrangement can be done in a two different ways. You can see that in the first way, that is what it is here, is known as the square close pattern. In this method, we arrange the particles, all the particles in the same line. You can see that, and we do not leave any gap. So each particle, all the particles, either they are arranged in the same manner. So one particle is above the other particle and one particle is exactly in the row of the other particle. So you can see that we have arranged them in this manner. See, this is how we arrange them. And then the next line, this is suppose A line, then the next line is exactly like A line. We do not do any changes and we arrange and the third line is also similar to the A line. This is what we do. So it is A type of arrangement, and in A type of arrangement, if you look into a particular particle, then you can see that 1, 2, 3 and 4. These are the four particles which touches it. So they are the nearest neighbor, and here the coordination number. The coordination number is equal to 4 here. Now what happens? We arrange the particles in some another manner. You can see here, I am trying to explain you. Suppose we have arranged this A line. This is your line A. Now we want to arrange the next line, but we don't want to arrange the next line similar to A. So now what we'll do, we will put the next line in such a way that the next line, not exactly, the next particle is not under the previous line. but it is in the gap of the previous line. You can see here this. This is where we put the particle into the gap. So this particle and this particle are not in the row, but they are differently arranged. You can see them. So as they are differently arranged, you can see that the third line that we can make goes very similar to the first line. So this first and third line, they are in the same line. So when you arrange them, you have this arrangement in such a way that the first row is A, then the another row is different from A and we call it B row. Then again the third row is similar to the A and the fourth row is very similar to the B. So this kind of arrangement I have already shown to you, my dear students, that this is the A kind of arrangement, and then the B kind of arrangement is done in the gap of this. Then again, when we put the particle into gap of the B line, then they are exactly arranged according to the A line. You can see that they are arranged according to the A. And then again, if you compare the B, then the fourth, like second and fourth are very similar. They are above and under to each other. So you can easily explain them. And this is how, my dear students, you can arrange them either into the A type of arrangement, or you can arrange them into the AB type of arrangement. When you arrange them into the A type of arrangement, in two dimension, it is called square close packing. And here your coordination number is equal to 4 because each particle is bonded or each particle is directly attached to the 4 particles only. But here if you look into this particle, my dear students, I am talking about this. This one is directly in contact with the 6 other. See, 1, 2, 3, 4, 5 and 6. So this particle is in contact with the other 6 particle 1, 2, 3, 4, 5 and 6, and that is why the coordination number in AB type of arrangement we will get the coordination number 6. So my dear students, when we arrange the particles in two dimension, we can have two different types of arrangement. The first type of arrangement is known as the A type of arrangement, in which this arrangement we call it as a square close packing, and in the next type of arrangement we arrange the particles into the AB type of arrangement, which we call it as a hexagonal close packing. And in hexagonal close packing, the coordination number is 6. In a square planar, in a square close packing, the coordination number is 4. So let us read about the text. In one way, constituent particles are arranged. In one way, constituent particles are arranged in the way that one row is absolutely equal to the other row. So the rows are absolutely equal to the other row. One constituent particle is arranged above and under the another constituent particle. This way the constituent particles are arranged so that each constituent particle is in contact with the 4 other constituent particles. The arrangement is called the square close packing, and here the constituent particles are aligned vertically as well as the horizontally. It is also called AAA type of arrangement, and in AAA type of arrangement we have coordination number 4. Now my dear students, we are going to study about the another way. So in the another way, my dear students, if we study in the other way, one row of constituent particle are arranged and the second row is arranged in such a way that the constituent particles arranged in the second row are arranged in the gap of the first row. So when the second row is arranged in the gap of the first row, such arrangement is called staggered manner. Such arrangement is called staggered manner arrangement, and gaps are also called the depressions. If we call the uh, if we call the amounts of the first row is A type, if we call the first row is A type, then the second row is different from the first row and we will call it as a B type. So we have, so now the third one will placed in the depression of the first row. So it will be exactly like the first one, and this is how This is how we get AB, AB, AB type of arrangement. And this AB, AB, AB type of arrangement, in this arrangement, each constituent particle is in contact with six other constituent particles. Such arrangement is called the hexagonal close packing, and the coordination number in hexagonal close packing is 6. This type of arrangement is more efficient as less space in the is left among the atoms. So my dear students, the hexagonal close packing arrangement is more efficient arrangement because more space is left inside it, and that is why the hexagonal close packing or AB type of close packing is more efficient as compared to AAA type of arrangement or square close packing. Please remember the efficiency of both this arrangement. The hexagonal close packing, the hexagonal close packing, we have some voids there. Voids are of two type, my dear students, in which the apex of the triangular